About a year and a half ago, we were doing some work with IBM in Smarter City, in Smarter Planet, kind of their big concept around Smarter Planet. And IBM asked me to give a keynote at Impact. If you've been to Impact, IBM Impact, Las Vegas, during one of the general sessions. And I said, really, you want to talk about agriculture when you have your most important customers from around the planet here to talk about IBM? You got, an Impact was 9,000 people, right, in the audience. And they wanted me to talk about agriculture and IoT and technology. And the guy after me was a guy named Kevin Spacey, right? So, do you really want that? And their point was, listen, this is really important stuff, right? How we eat, how we grow food, the availability of food around the planet is a challenge, and we think that's something that's really important for IBM. So I started off and I said, thanks for the opportunity. Or when I gave my talk, I said, either you're in the wrong place, you may be thinking you're in the wrong place, or I am, right? Because we're going to change gears. We're going to talk about food and ag, and you're here to talk about, big systems and hardware and things like that. But, in the end, I think most people realize most of the planet, or much of the planet, focuses on food production and serving it and growing it and those things, and we certainly all eat, right? So we're all invested in making this work. So I grew up in my family's farm just east of here in Fresno. So we grew table grapes and raisins and some wine grapes, and so my background really is in farming, but 20 years in software. So after I left farming, I spent 20 years in software, and when I came back to ag tech in 2009, it was really to marry the two of how to help a farmer make a better decision. And so when we talk about you can't eat data, it's really just an analysis of, while it's really important to understand how the farmer works and what information they can help with, the reality is we have to grow things. Right? We have to use water, we have to use land, we have to use people and machines and so forth to help the planet feed itself. So, bit of a history, not a lot of history. So farming is, there's many studies on how old farming is. One such study says farming is at least 12,000 years old. So if you go back to Australia, we Aborigines burned the dry Sahara, or the rainforest, the drier rainforest, in order to make hunting easier. And what happened was we got grains and small potatoes and other things that would come up because they now had sunlight. They had some ability to kind of thrive in kind of very dense areas. And people started cultivating those things, started finding out they could eat, grains and potatoes and other things other than meat. And so I bring that up because I call this Ag 1.0. Basically it's this kind of like pre-ag. This is like Ag beta, right? So we changed the environment in order to improve what we were doing, right? From a diet perspective. And that was an instrumental and significant change in how people kind of work together. So they work together, end up working the land together. They end up growing, small communities, and were able to be, less nomadic and more situated in a location. And as a civilization started growing. So Ag 1.0. So this is kind of the techie side of ag, right? So we'll call this Ag 1.0. Ag 1.0 is really how do you take that kind of randomness and move it into something that's more organized. And so somewhere around a couple thousand BC to 1920, we did that with people. So heavily farmed most of the planet, 40% of the planet actually grew something, right, or worked in farms. And it took about 2 acres to feed a single person. Not really efficient. Most of that was really small farm holders, where very small acreage. There was not a huge commercial undertaking around farming. That was really yet to come, and most of them were just kind of growing to eat. Something changed about 1920, right? So 1920, two things happened. One is mechanization came into agriculture. So this is what we call big iron. So there's tractors and combines and tillers and things like that. And then synthetic fertilizers were invented. And so companies that invented synthetic fertilizers allowed farmers to grow more intensely on the farms that they had. And so we went from feeding one person with 2 acres to feeding 5 person with 1 acre. So huge growth in capability for a farm to produce. And we saw this emerging of commercial farms. So these were people that were now growing and selling versus just growing and using for themselves and maybe selling a little extra. And what happened was people that didn't do that didn't commercialize, fell behind. So small farm holders, people that weren't investing in the technology of the day, ended up falling behind everyone else. And you get this now dichotomy of really small farmers and really big farmers as technology drove competitive pressure. So we're in a new phase. So most people have heard the term that, by 2050, or the statistic by 2050, that there'll be 9.5 billion people on the planet. That means we need somewhere between 70 and 100% more food to feed the planet. And most people believe that technology is the way we're going to do that. So we're not going to, because we have about 2% more arable land, we're not going to go find more of the planet in which we're going to put a bunch more crops on and grow them that way. So we actually have to now shift to this use of different types of technology, we think data, in order to help the planet make better decisions, grow more crops, be more sustainable in the use of crops that it does grow. So this pressure of the planet is really creating a gap. So there's some really interesting, and I'm not sure if there's a cause and effect, but about 1920 we had 2 billion people on the planet. We have added 1 billion people on the planet every 15 years since then, right? So we went from kind of really small to 2 billion, and then now we're just kind of on this growth stage. Pretty interesting, obviously a lot of pressure to grow food. There's also some other things that are changing. Today, the US and Europe is most of the middle class incomes. That will change by 2050. The US and Europe will be around 20-25% of the middle class, and China and India will be the lion's share of the middle class. So if you think about a couple things, and what do we enjoy in the US and Europe? Our diets are much different than diets in those markets, right? So studies have shown, Taiwan's a great example, when the gross national income of individuals increases significantly, their diets change. They go from eating rices and things like that to wanting meat and produce and vegetables and specialty items, nuts and other things, because they have income to spend it on. And so that's in China, happened in China. It's happened in Taiwan. It's happening in markets all over the place. And so if you think of not just the people are growing, but also that their diets are changing. Their caloric intake is going up, and they're wanting more things that we enjoy like in the U.S. And so the combination of those two really creates that pressure of additional crop demand. And unfortunately today, if you look at this graph, the yield graph is going in the wrong direction, right? So the bottom part of that graph is the way we're growing crops today and the amount of growth across all crops, that's 1.4% per year growth. We need to be at 1.75 to meet that demand. So while we're pretty close to where we need, we're where we need to be today, over time, that's going to create a huge yield gap. And that yield gap creates pressure both for price of food and availability of food, which historically has created unrest around the world, right? So it's not just making sure people have, almonds or meat or, fresh vegetables. It's also, is there unrest in areas where there's food pressure? So most people believe ag tech has the potential to completely reshape global agriculture, right? So when we say reshape, we're not going to be growing yet a new different kind of crop. It's really, how do we take data and information and sensors and allow a grower to understand better what they do and be more efficient at what they do? And that will reshape not only farming in the U.S. and countries like the U.S., but in small farm holders like in China and in India and in Africa. So we'll start now shifting to talking about the farm and the farmer and how they make a decision. But this is really, most people don't understand this. Growers have 40 chances to get it right. So if you think of, so what I mean by that is, if you look at a farmer, when they start farming to when they're done farming, they have 40 seasons in order to get it right. That's it. So when you think of a farmer and their perspective of adopting technology, changing practices, if they get more than one or two of those 40 chances wrong, they're probably going to be out of business. Okay? So when we introduce technology and data science to that farmer, that's the perspective that they have. I got 40 chances to get this right, if I'm lucky. I better not make a lot of mistakes. What I do has to be right because I'm banking my entire business and probably my kids' business on one of those chances. So what we're seeing today now is what we call what we've been calling Ag 3.0. This is really where we take technology, connected devices, sensors, data systems, and we bring it together to help a farmer make decisions about their crops. And so several components to that, and I came out of sensors and soil moisture monitoring and so forth. What we're seeing today is where this march for connectivity on the farm, so sensors in the field, on plants, in the ground, weather, and so forth are becoming pervasive in farming. And I've said for some time is I believe in my lifetime I'll see every plant sensored. Right? We will get to the kind of a price point that a sensor will be put on a seed when the seed is sold, and it basically measures that plant's health and status as it grows. And I truly believe we'll see that. We see now the ability to create action-driven analytics for a farmer, and that's an important component. If you think of data science in general, the farmer is a very different consumer of information. They spend most of their time in their pickup. They don't have 3 monitors in front of them in which they have an Excel spreadsheet and pivot tables. They're trying to figure out what's going on. They're very much to the fact of, listen, I've got a bunch of decisions to make today. If you need to help me make those decisions, right? So actionable information is really important. So that's turning the data into action is important. We're going to see with Ag 3.0 diversification. So diversification of crops and as well as land. So in areas like in Africa, where we have rich soils and good water in many cases, you're going to see the ability for data systems and data analysis to allow that type of grower to grow a more diverse crop. So instead of taking crops that are grown in other areas and then transporting them a long way away to Africa or other places where the demand is, they will grow more locally. And diversification is great because it solves a lot of needs. You've got organics, you've got local grown, you've got big ag commercial. Diversity allows us to spread that and allow those, or spread data and allow those systems to grow and those types of growers to grow whatever makes sense for their locality. And we're seeing that in the U.S. and like places like Nebraska, and they're growing pumpkins where they used to grow corn because they've got local demand and they've got the ability to manage that. Data and data systems are going to allow us to create transparency. You will see this, in particular, accelerate for consumers. So consumers more and more want to know where my produce came from and what went into that produce. And I want to know now. I want to be able to go to the grocery store scan a code in the aisle, and know where that came from, what chemical was applied, how much water was used, and how old that produce is, and where it went, and who touched it. So data systems and information and tracking and sensors are the only way we're going to answer that question. So transparency to the customer. And then hyper efficiency. So as the market increases and the amount of demand increases for produce, farmers become extremely competitive on how they produce. Only the very successful ones that adopt technology will be successful. And that's because they're going to be hyper competitive on efficiency. They're going to look for every way to reduce the resources they apply but also allows them to maximize their crop or their crop consistency. So that demand for hyper effective or hyper efficiency for a grower it's actually reaching us now. So if you look back on data in agriculture, if you go back just a few years, there wasn't a lot. There wasn't a lot of connected sensors. And I'm really talking about data. This is both IoT data as well as imaging and weather. Right? So kind of a generally purpose data for agriculture. We look back, a typical farm had about 5 data points per day that they got access to. Weather primarily drove that. And not a lot of connected sensors. We think there was about 100,000 connected sensors in the year 2000 in agriculture. So you're talking tractors and everything else, not a lot. By 2020, we expect about 2 billion connected devices, tractors and sensors and other things. And the average farmer will have about 190,000 data points coming at them every day. So if you think about the farmer and you go from, I've got 5 pieces of information in my head, I think I'm okay with that, to now I have 190,000 coming at me every day, oh God, now what, right? So we already see farmers today go, listen, I already have way too much information to manage. They describe it as this tsunami of data that comes at them, and they need better systems in order to make those decisions. And then by 2035, the average farmer will have about 4 million pieces of information coming at them every single day, right? So today, farm management systems are really nascent, right? As far as a data management platform, they need to grow significantly in their ability to analyze and make sense of the data that we're providing back to the farmer. I'm hooked on a drug of information and productivity, right? 7th generation corn farmer out of the Midwest, realizing that the only way they're going to stay competitive in the marketplace is this, not only embrace, but lead in data management and how they use information. Huge departure from how growers and farmers managed 20 years ago, when many of them would walk in the field and dig a hole or kick the dirt and make a decision based on their instinct. So what are these systems looking like today, and where are they going? So on-farm, our system, this is how we see the world, in that we have this data aggregation problem, right? So the companies that produce sensors and data systems and information in the marketplace today are scattered. I like to call it the Tower of Babel. Every data system, none of them really talk to any other data system. All the data types are different, and there's a lot of confusion about how to consume data. It's really very messy, and there's a lot of variability in information, from soil data to weather data, imaging data. And so we're focused in particular on how do you aggregate that data up, bring it all together so you can actually make decisions from that point. We think that data systems of the future have to do this, right? You can't be focused exclusively on one data type, because farming is much too complex to say, hey, I need to make an irrigation decision, so let's only look at the weather. Let's only look at the soil moisture. Really not a decision either. You need to bring that data together in order to be able to analyze it and then provide it back to a decision process. And it's got to be a closed loop, right? So in the end, you take that data, you analyze it, you help a farmer make a decision, you bring results back in of what happened, and you adjust that going forward. So farm management systems of the future will have to do this in order to be successful. And that closed loop will allow those things to flourish. So we think of, when you think of a grower, this is a bit redundant, but you've got the data that's coming in, the analysis, the knowledge. Where growers really get interested is in knowledge, decision, and action, right? So they're not terribly worried about the moving parts of the data systems. What they're really focused on is, can they trust the information that you're providing them? Does it correlate with what they're seeing in the field? And then they can make action on that. And that, in the end, gives us a lot of capabilities. So where are we today in our data, in our growth, and what's going to happen in the future? So if the world grew like the U.S. did today, we'd be okay. We're actually exceeding what we need to be on a global basis. The problem is that the world is far behind what we need to do. So and I bring this point up because you can't take the model of the U.S. and put it into Africa and make it work. Growers in the U.S. are large. They invest a lot of money in hardware and equipment. And they work much differently than a farm in Africa or India or China does, which is, a farm in the U.S. is about 450 acres on average. The average farm in Africa is about, 2 acres, right? And very little capital to invest in hardware. A lot of capital we invest in hardware today. So it's really a different customer, right? So we're not going to take the big iron of 2.0 and say, hey, just grow that way and you'll be fine, because they don't have the capital to invest in it. They don't grow that way. So really it's information and data systems that will allow them to skip the 2.0 and to grow more efficiently, because they're able to make a better, more informed decision about the crops they grow today. So what changed in ag, right? Why is ag all of a sudden interesting? A year and a half ago, Monsanto bought the Climate Corporation for $1 billion. The Climate Corporation is a data science company that no one in agriculture really knew. I mean, we saw them at a trade show right before they got acquired, and they had a little 10 by 10 booth, and I talked to the guy, and I'm like, what do you do? We do weather. Okay, what does that mean? Well, we do weather insurance. Okay, what does that mean? And after the acquisition, I talked to some people I know in the industry that are big companies, and they're like, we don't even know their name. We have no idea who they were. But Monsanto said something differently. Monsanto said, we don't think seeds and GMOs and chemicals are going to be what we are in the future. We're kind of seeing a peaking of that. We think data is where ag's going to go, and we're going to make a big bet first on what that looks like. And so they acquired the company. They had 75 data scientists, pretty big, pretty lot of power on there, because they knew that information was going to be the way they were going to be competitive in the marketplace. And the CEO of Monsanto said, data for us is a $20 billion a year business. That is a huge, huge number. And it woke the industry up into what's possible and where we're headed. So this is very general, and I'm happy to answer very specific questions. But what we see, takeaway-wise, is that you will see farms always on and always connected. Growers we see today using our systems and other systems are logging in all day long, trying to understand what's going on in their field all the time. They want data. They want data at high rates of speed. We've got growers that they want their sensors reporting every 5 minutes. Because they just want to be aware of what's going on, and they want to be notified when there are problems, because a problem means they're going to lose something. They're going to lose yield. They're going to lose. They're going to end up putting more resources than they want to. They're going to make a mistake, and mistakes cost money in agriculture. All that's knowledge-based. We also need geeks. We need data geeks. We need people that maybe not are domain experts, but will come into agriculture and help us bring new thought around how we analyze the data we have today and how do we make that leap. Right now, agriculture's got a really limited set of data people. That is changing. There's about $4.2 billion will be invested by VCs in ag tech this year. We're going to be spending a lot of money on hiring a lot of people. A lot of companies will. And so you'll see a lot more interest, and we want to drive interest into the market. Farmers that adopt ag tech 3.0 data systems will succeed. Farmers that don't will die. It's a strong statement, but that's the same thing that happened in Ag 2.0. It will be identical in Ag 3.0. If you're not analyzing your data on your farm, those farms will be non-existent. And lastly, we expect small farm holders like in Africa and other places are going to skip Ag 2.0. They're going to skip buying the combine for systems like Watson, right, where they can call up on their phone and say, what do I need to do today? And some system will have analyzed their field, their weather, their crop, and it will tell them, you need to apply 2 pounds of fertilizer today. Or you need to do this today. Or the weather's going to be this tomorrow, and so you should do this today. Small farm holders in those markets will look for those systems because they're democratized. They're easily consumed the way that they have access and use of information today. That's it. We've got a few minutes left for questions, and I'm happy to answer those.